Previous good morning class. Welcome to Summit Critics. So previously we will basically start with the modes of failure. So today we will basically telling about how the load bearing implants will fail due to the corrosion, wear and fatigue. So basically the corrosion is the mostly responsible things what I have mentioned before, and wear is the basically the physical phenomena, and wear basically uh, work as a catalyst in case of corrosion. And the fatigue is the things basically it is also known as cyclic loading. Okay, so cyclic stress will occur. So in case of corrosion we have different standard, ASTM standard as well. So what checks the different material failures, like ASTM G61 to 86 and so on so on. So what's happened, so basically we'll start with wear. So because wear is the another condition for corrosion as well. So in case of wear, what happens that abrasives comes into the picture. Different abrasive comes into two layer, or some adhesive wear is also occurring. Okay, so different material just touches with one another. So just mechanical phenomena wear will occur. So sometimes over the bearing surface, this kind of adhesive words will taking place. And abrasive words basically two dissimilar word. There is another foreign particle. So then only abrasive word will take place. And fatigue word due to the cyclic loading. So one surface touches with the another during that cyclic stress. And next is the corrosion words. So or corrosive words. So so those are the mechanical phenomenon of wear. And this is the chemical reason for wear. So now comes to how that corrosive wear will take place. So corrosive wear basically have two effects. So one is premature due to that corrosive wear. Basically, what's happened? So metal implant will be weakened and premature failure will occur. And what's happened in case of corrosive wear? So basically, that when the cell adhesion proteins and a corrosive works comes into the picture, so O2 concentration near the cells is kept low. So dissolved metal ion is accumulated near the cell, and Cl minus ion may be accumulated near cell, and decrease in the cathodic reaction and decrease is of the protectiveness of passivizing film. So cell adhesion to the surface of the metallic biomaterial will occur. So type of corrosion. So basically there are three type of corrosion. One is galvanic, another is stress concentration, fretting and pit corrosion. So those we have basically mentioned in our previous class also. So once again, just in short, I will mention that in case of galvanic corrosion, two different metals being used. So basically happens in case of while we are using stainless steel screw over the titanium plate. And stress corrosion, presence of crack due to the stress. Fatigue basically cyclic stress, not only stress. This is due to the same the presence of crack due to the cyclic stress. So pit corrosion, a local form of crevice corrosion due to the abrasion produce a pit. So which metal prone to which kind of corrosion? So basically SS or cobalt based alloy are prone to pitting corrosion, and SS 316 stainless steel crevice, and so on what has been mentioned here. There is no such kind of things to know, just read it, and whenever you are going through those points, so you will definitely get answer. So also the implant location, which portion will be more prone to which type of corrosion. So you have to take care, like pitting is mostly going through the dental part, crevice is bone plates, corrosion is the bone, fretting, ball joints, and so on. So so now comes to the corrosion of the orthopedic implant. So in case of orthopedic implant, both temporary implants of like plate, screw, and sometimes going for total prosthesis also. So basically we have going for the orthopedic implant like hip, knee, spinal, shoulder, toe, and etc. The corrosion mechanism that occurs in the temporary implants as crevice corrosion at shielded site. The main cause of the failure of the orthopedic implant is wear. So what I mentioned before. So the wire always act as a catalyst in case of corrosion. High wear resistance material, that is why we are using like ceramic or going for surface modification technique as well. So this corrosion will be minimized by also using the different combination as well, like metal on plastic, metal on metal, ceramic on plastic, ceramic on metal. Sometimes for different metal, like metal on metal, like in case of knee joint or hip joint, we are basically used used polymer or soft material between two metal plate also to decrease the wear effect as well as the corrosion over it. So in case of metal on metal, metal and plastic cup, so maybe it is very good for hip implant as well. Like the acetabulum cup is made up of polymer cap, like ultra high molecular weight polyethylene, and the femur set is basically made up of metal like stainless steel or titanium, but that wire rate is 0.1 micro millimeter in each year. Next, metal ball on the metal cap, so maybe it is active lifestyle younger patients, so much more durable. So like a sporty person can use it, where it is very less 0.01 only, but sometimes a knocking sound will come as there is a metal on metal, so there is no soft tissue has been used between two material, and sometimes the metal ion also released into the blood, so it will sometimes um, a carcinogenic effect also seen in case of if it reacts with the biological fluid, so this kind of effect is also comes into the picture. And also ceramic on ceramic based of for all good combination, longevity, wireless is very less, and also respect to the crash and scratch resistance also, but it is very costly as well. Next, ceramic on plastic, so this is also good combination, very reliable material also, but the wire rate is little bit more than the ceramic on ceramic. And sometimes we are going through this oxynium ions for hip implant, but they are very costly, but wireless is very less, just wire means we can reduce by 98% up to, so we can say there is no wear as well. Also some great aesthetic view also, strength is very high, and so on. So those are the material are good in aesthetic view as well as mechanical point of view as well as physical so oxynium also based on the oxynium and zirconium. So zirconium itself is a very costly material and is very good in case of oral implant as well. So this kind of material is basically used. So just by changing the composition of material like metal on metal or metal on plastic or metal on so on, so we can decrease the wear rate such a way that 97%, 98% and 99% during why we are using ceramic on ceramic. So in case of corrosion on dental metal, so similarly for dental metal, in case of dental metal, pH factor is very important. So during the change of pH factor, that chemical reaction will take place. So we have to take care what material we have used. It will sustain in that pH zone as well. And also it is also prone to pitting corrosion as well as fatigue corrosion also during the chewing operation. So corrosion of spinal implant. So basically spinal implant is modular spinal implant are aid to obtain fusion, get fritting and corrosion. So basically fritting corrosion is comes into the picture in case of uh, in case of spinal implant made out of steel, stainless steel. So maybe it will be if we can minimize those spinal implant uh, corrosion by using different materials and by checking the surface finish of the material, so we can minimize the localized charges. And stainless steel is implant with rigid interconnection, and those are different surface finish of the rod and connector. So like what I mentioned, like there is in case of spinal implant we can go for screw, a disc and plate kind of implant. So just by changing those we can also reduce the corrosion on the spinal implant. So and also if we certain extent we can decrease the corrosion like passivation, polishing, just by changing the surface modification technique. So those are basic surface modification techniques, you can go through the internet also, like biomimicking processing, electrophoric process, ion implantation, thermal spraying, pp, polymeric vapor deposition and laser treatment. So in future days we will basically going through those part also. So how can the corrosion protected by surface modification technique? So in conclusion, we can say by changing the material properties and the combination of material, and as well as the checking the pH factor, sustainability in that, by checking that what kind of pH, in which zone we have used that implant, what is the pH factor of there, and how much it is chemically inactive in that zone. So we have to take care of those things. So in that way, we can reduce the corrosion related problem as well, and also we take care about the wear also. So less wear means less corrosion as well. So that's all for today. Thank you.